Now, let's say you have the same graph. Let's say you have the same graph, but the graph this time is for a sphere, and it's a hollow sphere. Okay, so it's a hollow metal sphere. How would the graph look like? So, क्या बोलते हो आप? Hollow metal sphere. Right. So hollow metal sphere. So the charges would be on the surface. কিরকম? তো ভিতরে কিছু হবে না? ভিতরে চার্জ নাই, but field তো থাকতে পারে. So what do you guys think? কি হবে এটা? How does the graph look like for a hollow metal sphere? Same as the previous one. ভিতরে তো charge. Right. There is no field inside, right? So এটা এখানে তো show করতে হবে. তার জন্য কি থাকবে? Flat. Okay. So it's flat and then it goes to the top because suddenly from the surface all the charge shows up. All right. So yeah, এটা হচ্ছে তোমাদের graph. Now both of these graphs, একটা জিনিস একটু clarify করি. Outside the sphere, they all follow what law? Inverse square law. So আমাদের এটা হচ্ছে you have to know because inside the sphere কোনো mathematical implication night on the syllabus. Right, so these are two spheres and they have your field that's around the sphere. So this is number 1, 3. This is field between two spheres. Right, that's the problem because they take question there. So yeah, that's a solid sphere, solid metal sphere. Yeah, so what happens in a solid metal sphere is that, let's say you have a metal sphere like that, and you have charges out here. Let's say it's a negatively charged sphere. So once it's a negatively charged sphere, let's say the negative charges like that, they will not stay here. And the reason behind that is that they're feeling what from each other? Repulsion, right? So what will happen is the charges will all move to the surface. So the charges that you see here, they'll move to the surface like that. And once again, your field will be the highest at the surface. Now, how would the field be inside the surface? So in this case, we assume if it's hollow, the field is actually there, but the problem is the field is cancelled out. So let's say you're here, you're a charge here, and it's a hollow sphere, right? Where is the field coming from? Every direction, right? So what's your net field? 0, right? So similarly, we find that if you go here, your distance from here increases, right? So field should decrease, but your distance from here decreases, so field increases. So in a hollow sphere, we find that the net field is actually what everywhere? Equal, right? But in this scenario, the one with the solid sphere, this one, right? So let's say it's a solid sphere. You don't have a net field inside. So the field is consistent throughout, because you can't go inside it. There's no place to be inside. So we can't actually measure any field inside. So we keep it flat like that. Now, if this was an insulator, what would you have is the field would be increasing from the inside. Why is that so? Because in an insulator, the charges will stay where they are. So as you start to move from the inside to the outside, what happens is the charges build up. So your field strength builds up. Here, there's no building up process. So we just keep it flat. Distance? A distance. Distance from the center. So আমরা যখন point charge নেই, right? The center is the place where all the charge is. So আমরা গ্রাফটা start করি হচ্ছে এভাবে from the center, like that. Now, whatever it's in the field. So এখানে যে electric field এর ভ্যালুটা পাচ্ছি আমরা, let's say যে এই ভ্যালুটা, right? Some number. এটা মানে কি? Just একটা number, the example they বলি. Let's say this is 12 Newton per coulomb. What does that mean? At this location, right, distance x, right? If you place a 1 coulomb charge, how much force will it experience? Yeah, so that's the experience. Okay, let's have a Let's draw the graph for the field between two charges. এটা হচ্ছে খুবই important. Okay, I can't emphasize enough. Out of all the graphs out there, this is the one that you must just you have to remember somehow. করার কিছু নাই. So this is electric field strength. Metal sphere. এই যে hollow metal. ওটা নাই ওটা just hollow আছে. Because সলিডের ভিতরে এটা হচ্ছিল assumption করে করতে হয় হলোটা করা লাগে because হলোটা আমরা বের করতে পারি there's like strength from this side strength from that side right so this is Newton per coulomb this is distance d meter we are assuming these are point charges okay so just আরেকটা বলে রাখলাম এগুলো point charges and আমি একটা গ্রাফ ড্র করব I want to do the reverse because প্রত্যেকবার আমি ড্র করে ফেলি তোমরা চিন্তা করো না নিজের জন্য so আমি এখন একটা গ্রাফ দিচ্ছি see if you can figure this out so the graph that I have between two charges electric field strength looks like this and I think you get like a 3 or 4 mark question to explain what the charges are not only you need to explain what the magnitude of the charges are you also need to explain what the nature of the charges whether they're plus or minus so এটা যখন গ্রাফ দিবে you need to figure out two things একটা হচ্ছে nature মানে হচ্ছে polarity মানে plus or minus ওটা বের করতে হবে দুইটা চার্জের আর আরেকটা জিনিস যেটা তোমাদের ফিগার আউট করতে হবে কার ম্যাগনিটিউড কতটুকু so there are some questions where value দিয়ে তোমাদেরকে ফিগার আউট করতে হবে কোনটার বেশি চার্জ কোনটার কম চার্জ okay so the other one is the magnitude of the charge magnitude so yeah this is the graph that I have obtained between 2 point charges can you tell me what should the charges be huh? Okay how many of you think that they are opposite charges sure Achha, okay how many of you think that they are like charges same charge what happens Achha এটা তো ঝামেলা হয়ে গেল কেমনে বের করব আমরা সো ইলেকট্রিক ফিল্ড স্ট্রেংথ যারা বলছো যে এটা হচ্ছে লাইক চার্জেস নাকি unlike charges also right why so they're experiencing the same throughout and your argument is that there's no null point আর yes এটা তো হচ্ছে আমার হচ্ছে যদি দুইটা লাইক চার্জ হয় যেটা তোমরা বলছো দুইটা লাইক চার্জ হলে কি প্রবলেম that there can be a location where this charge is experiencing what from the one here repulsion it is experiencing what from the other one as well repulsion and since the vectors are acting in opposite direction there is a possibility that they will watch each other cancel each other but এটাতে দেখো if you look at the graph I've provided here there's a low value যেটা আমাদেরকে explain করতে হয় but it's not a what value though zero value so what does that mean it means that there is a consistent force acting on this object in what direction same direction এটা যদি কোনো সময় এক্সামে আসে যাদের কনফিউশন হচ্ছে the way you should work is you put a what charge here a test charge okay test charge দিবা test charge দিয়ে see which way the arrows are pointing so test charge charge সবসময় কি কনসিডার করা হয় positive okay so test charge is always positive charge here so you have a positive test charge the positive here will what the positive repel the negative will what the positive attract is there any instance possible where these forces will be in opposite direction no right is it possible to mathematically cancel out two forces in the same direction no right so you'll never have a null point here so yeah the correct answer is going to be opposite charges but then why do we have like the minimum here it's the furthest away from the charges yes exactly so essentially যেটা হচ্ছে আমি বলি এই গ্রাফটা কেমনে অবটেইন করা হয় তোমাকে একটু এক্সপ্লেইন করি একটা চার্জের গ্রাফ দেখতে এরকম like one of the charges or নিজের গ্রাফটা এরকম দেখতে ছিল where it dies out almost to zero and then it becomes zero like almost like that এরকম এটাই গ্রিনটা হচ্ছে কার গ্রাফ এই যে এটার গ্রাফ ওকে আর on the other side রেডটারও একটা গ্রাফ আছে ওইটাও হচ্ছে এরকম দেখতে And what does it do as well? Following inverse square law, it also dies out. আমরা যে blue graph টা draw করছি, it's actually not the graph for one of them, it's actually the graph for what? Both of them are resultant. So resultant যদি এই মাঝখানে আমরা হচ্ছে add করি, again if I want to find the resultant right at the center there, এই জায়গাটাতে, they're very low, but দুইটার কি ভ্যালু আছে না ছোট ছোট, so দুইটা add up করলে কি পাবো আমি, এই blue ভ্যালুটা পাচ্ছি. So at that particular location you're the furthest away from both the charges, right, in terms of হচ্ছে common একটা distance, therefore you have the lowest force acting on it. But there's another issue out here. Can you tell me whether my charges are কোনটা plus কোনটা minus? মানে এখানে আমি left এরটা plus দিলাম, right এরটা minus দিলাম, right? Should it be this way or should it be the other way? Yeah, we can't tell actually. Because the graph here doesn't actually tell you the nature of the charge. It rather tells you the magnitude, and I'll tell you why. এই যে এখানে যে plus valueটা show করছে, it doesn't tell you it's because of a positive charge. Rather, it tells you the direction of the field. এখানে positive value মানে হচ্ছে the net field is acting which way? To the right. And throughout the process, আমার net fieldটা কোন দিকে act করে? To the right. So as I end up there, isn't the force still to the right? What do you end up with? A positive value. So there's a positive value throughout here. So the positive represents what? Direction of the net field. Represents direction of net field. Right. আচ্ছা, মানে you place a positive charge in the field and এটা repulsion এদিকে দিচ্ছে, ওই যে ওইখানে প্রবলেমটা, I took right as positive, right? Right to negative হতে পারে. The direction right in my question is considered to be what? Positive, right? What if we took right side as negative? How would the graph look like? Even with a test positive charge. Same graph হবে, just mirror হবে. Because আমার right side এখন কি consider করছি আমি? Negative, right? So wouldn't the graph be the same just on the other side? So from an electric field strength graph, right, it's not really possible for you to find the nature of the charge. You can find the magnitude, you can find the direction, but not the nature. Nature of the charge বের করার question আসে তোমাদের, মানে বলতে হবে প্লাস নাকি মাইনাস, ওটা কোথায় আসে? Potential. কারণ potential-এর ফর্মুলাটাতে the plus and the minus actually means the charge. এটা তো একটা vector representation, nothing else. Okay. Right, so that is it. এখন can you tell me which one is stronger in charge or in its strength? As easy one. Yeah, this one, because it starts with the higher value here. Okay, so this one is higher magnitude. কোন পয়েন্টে পজিটিভ চার্জটা, রাইট? সো এখন যদি কোয়েশ্চেন আসে তোমাদের, এটা আমি পড়ি নাই, সো এখন ডিসকাস করি। ইফ দে আস্ক ইউ টু ফাইন্ড দি স্ট্রেংথ এট দিস লোকেশন, এই যে এই লোকেশনটাতে স্ট্রেংথ বের করতে বলছে হিয়ার, হাউ ডু ইউ ফাইন্ড দ্য স্ট্রেংথ? হোয়াট উড ইউ ডু? The y value, this minus this or this plus this? No, the net electric field strength at that location. That distance. Oh, so no, we don't have the graph. No, we want to find that value without the graph, like with values available for the charge. What would you do? So যেটা করব আমরা, yeah, net field বের করতে হবে। net field কেমনে বের করব? So we're going to find the electric field strength of this charge at that location. কেমনে বের করব এটা electric field strength? E equals to kq by d square. Our এইটার যে ফিল্ডটা, the other one here, this one's field, right? ওইটাই পয়েন্টে কত হবে? A equals to kq by x square, right? And if I want to find the net field, what do I do? So there are two ways of doing this, and it's all levels থেকে একটা issue. If you want to find the net field, you can add them with the sign included, or subtract them without the sign. বুঝছো জিনিসটা? Find the difference without the sign, or you just add them. মানে এটা কোথা থেকে আসছে আমি জাস্ট একটু তোমাদেরকে রিমাইন্ডার দেই। There's a box here, okay, and there's 5 Newton on this side, and there is 7 Newton on that side. How do you find the resultant? 7 Newton minus 5 Newton, right? But that's actually not the right way. What's the right way? Yeah, so you're supposed to add 7 plus minus 5, because direction to ulta dige. That's how you find it. So net বের করার mathematical way is to add. Net means addition, summation of everything. But if you want to add the things and you have to take into account the direction, what do you include in your addition? Sign, right? So if I want to find the net, I would recommend you always add them, but you take what into consideration? Direction, right? So F net or E net would be equal to এখানে plus minus তোমার ব্যাপার তুমি কোন দিকে নিতে চাও, but basically at the end of the day we'll end up getting a what of their difference, k cube by x square. Okay, up to you. একটা plus হলে একটা minus হবে. Now if it's a null point, right, what would it be equal to? 0. Okay, all right. Right, good question. So AQ টা is হচ্ছে AQ আর ওই রেডটা হচ্ছে এই চার্জটা। Electric field strength, we don't have any charge in the field because you're finding what? The electric field strength is the force exerted per coulomb charge. So তোমার এই Q1, Q2 যেটা, Q2 is what? 1. No. ওই যেটা experience করতেছেন electric field strength is considered to be what charge? Electric field strength definition কি? The amount of force experienced per unit positive charge. Unit charge charge কত? 1. তার জন্য যে Q1, Q2 যেটা, 2টা হচ্ছে 1 নেওয়া হচ্ছে এখানে। Okay, তার জন্য you don't have any other value there. Okay. Now, if you want to find force, what would you do? An actual force on a charge. তখন তোমার হচ্ছে কি করতে হবে? ওই actual chargeটার value নিয়ে কাজ করতে হবে. So it could be like 10 coulomb, 15 coulomb. ওইটা হচ্ছে Q2 জায়গায় বসাবে। Okay. Right. Now, how would the graph look like for like charges? I think তোমরা পারবা কি করতে হবে এখানে? Like charges এর graph কিরকম দেখতে হবে? Yeah, so it'll be similar, but একটা থেকে আরেকটার দিকে যখন যাবা মাঝখানে it'll be what? X-axis, right? And that's the null point. Null point কার দিকে বেশি থাকবে? So I'm going to give you a question. দেখো তো পারো নাকি? This is a question that Excel MCQ তে দেয়. 4Q plus 4Q আর এটা হচ্ছে plus Q. হ্যাঁ, so null point কোন দিকে থাকবে? Will it be more towards 4Q or more towards Q? The weaker one, right? Because the weaker one needs to have the charge much closer to be able to oppose that one's higher value, right? So it'll be something like this. It'll cross over and go there. Crossover to key indicate that the net field direction key change. So the net field is not acting which way? The other way. Okay. So yeah, these are the two graphs that we have from electric field strength. The question is, interaction. So tell me, what have you seen that has instilled fear in you? এটা হ্যাঁ, so আমার হচ্ছে এটা 4Q, right? আর এটা যদি 4Q হতো, where would the null point be? Middle একদম, because দুইটা ব্যালেন্স করতে পারতেছে, বাট এটার তো এত স্ট্রেংথ নাই। But strength বাড়াতে পারে। Strength কেমনে বাড়ানো যায়? If you are closer, right? So কাছে এনে you would have enough strength to oppose that one. Okay. বলো কি confusion? Negative কেন গেছে? হ্যাঁ, তোমার এটা হচ্ছে plus 4, right? So this is my charge here. This is plus 4 coulomb, and this is also my charge here. This is plus coulomb. And what we do is we take a test charge here, right? Can you tell me which way is this test charge, which is positive, experiencing force right now? To the left or to the right? To the right. So that way, right? Now, what happens is the other charge here is also applying a force. Which way is that applying force? To the left. Is it as equal or smaller? Smaller, right? So it's going to be like that. Can you tell me which was the resultant force acting? Right. Okay. Now, what happens is you keep going that way. So you're moving closer and closer and going that way further and further. And then you come to this location here where this is now much smaller. This is much larger, right? Which was resultant acting? To the left, right? Like that. And in between, there was actually a location where both these arrows were what size? Equal size. What was the resultant then? 0. So that 0 is this location here, the null point. Okay, and this is positive because it's to this side. Now, do you see this is the other way? So yes. So this graph could be this as well. Yes. বলো null point এ লোকেশন দেখে বলা যাবে যে কোনটা বেশি না কম হ্যাঁ কেমনে বলা যায় বিকজ যেটা কম হয় null point ওর কাছে হয় because it needs to be much closer to that point to be able to oppose it, right? So যত কাছে আসবা তোমার strength কম in terms of charge, but distance কমলে কি strength বাড়ে না? So that's why you're bringing it closer to you to be able to oppose it. হ্যাঁ বলো হ্যাঁ Okay, so bolo, before I move on to electric potential graphs. This one. No. The charge that's exerting it. The Q is always the charge that's been like exerting the field, not experiencing it. Okay, now the graph did to actually Tamiler because there are way too many combinations out there. This is a potential graph. So potential graph can be for just plus, just minus, between plus and minus, between plus and plus, right? Shabula different graphs. So it to carefully bujo. This I understand can be little challenging, confusing. So this is electric potential versus distance. And we'll be doing this only for what charge? Point charge. Inside the surface, a potential vapor is not part of your syllabus. Okay. So shall I do screen it? Let's see. This is D. This is V. And I will be giving you 5 different options. Pasta answer korte hobe, okay? A pasta sub possibilities, so should be done with this potential, right? All right, so to start with, the first one that we have here is a positive charge at the center. Second one hoche negative charge at the center. এখানে হচ্ছে এটা লাগবে না এখানে হচ্ছে you have a positive charge here and a negative charge there. Then you have a positive charge here and a positive charge there. Negative just same hobe তার জন্য দিলাম না, okay? So we'll start with the first one, V versus D for a positive charge. Can you answer? Parva, bolo. Tell me formula. What's the formula for V? Electric potential. Yes, V equals to KQ by D. And the Q here, right, is positive. So the V would be positive or negative? Positive, right? Okay, fine. Now, here's a question for you. And everyone, okay? এটার গ্রাফটা কিরকম দেখতে হবে? কেউ কি আমাকে বলতে পারবা? ইনভার্স মানে এরকম দেখতে নাকি এরকম দেখতে? First one. It can be both. Why? কি হবে? Both. কেন? Direction of what? এদিকে আর এদিকে এদিকে আর এদিকে আচ্ছা আচ্ছা এরকম Oh wait, that. আচ্ছা, okay. I'll tell you, এটার answer করা possible. And the reason why you can't answer this is because electric potential is based on what work is done by a charge within the field. I've given you what are you approaching, but what are you to begin with? ওটা তো answer করা হয় নাই. Are you a positive charge or are you what charge? Negative. Because if you are a positive charge and you come close to a positive charge, what will you experience? Repulsion. If you're a positive charge and if you're a negative charge, what will you experience? Attraction. And turns out, if you experience attraction, you lose energy. And if you experience repulsion, you gain energy. So এখানে হচ্ছে loss or gainটাকে signify করার জন্য we use sign. And the sign actually makes a difference here. So if you're losing energy, what sign is being used? Negative. So negative যে গ্রাফগুলো এখানে থাকবে, these all represent the fact that you're what energy as you're moving, losing energy. But if you're moving and gaining energy, gaining what energy, by the way? Electric potential energy, you'll have a positive value. So now questionটা answer করার জন্য first point হচ্ছে, how would the graph look like if I had a positive charge moving in? So এটা একটা positive charge moving towards a positive center charge. How would the graph look like? There's only one answer, by the way. First, this one. Yes, okay, that's the correct answer. Now, it actually ulta dikeo possible. Can ulta dike possible? It means that you're coming from which side of the charge? The other side of the charge. এখানে তোমাদেরকে যে জিনিসটাকে দেখতে হবে is your value of V what or not positive. And যখনই V positive হয়, I'll write this out here. Positive V indicates what? Indicates that energy or potential is what? Gained. And this happens when like charges interact. Okay, so whenever you have like charges interaction, তখনই হচ্ছে এই জিনিসটা হয়, you gain potential. Yes. Yes. Yes, because distance কমতেছে. But you could use the first one as well, problem নাই. Indicates that energy is gained. Yes, so think of it this way. You have a positive charge and you have a positive charge here. আমি এটাকে এখানে ছেড়ে দিলাম, ছাড়লে এটা কোন দিকে ন্যাচারালি যাবে? চলে যাবে, রাইট? বাট তুমি এটাকে উল্টা দিকে নিচ্ছ, সো উল্টা দিকে নিতে হলে এনার্জি কি লুজ করবে না ওকে এনার্জি দিতে হবে? হ্যাঁ, সো এনার্জি গেইন করতেছে, তার জন্য পজিটিভ ভ্যালু। ওকে, similarly, how would the graph look like if you introduce a negative charge here? Negative charge যদি positive charges দিকে যায়, right, what does it do? Yeah, it will lose energy, and the loss in energy is indicated by what graph? A negative graph like that. All the negative values here mean what? That you're losing energy as you're moving towards the charge, and that's how the graph looks like here. Okay, so what does it mean by the this is just so you have a positive charge here and you're bringing a what charge into the field? A negative charge. And when a negative charge enters the field, right, does it gain energy or lose energy? Yeah, তার জন্য সব negative value. Clear about this? আমি পাশে লিখে দিচ্ছি, minus কি represent? Minus V indicates কি হচ্ছে that energy or potential is lost, and this happens when unlike charges interact. Okay, now that being said, এই গ্রাফটা তাহলে তো একই জিনিসই হবে। What would the graph look like? কেউ আমাকে বলতে পারবা? Right, exactly. So same graph হবে. I'll just replace this whole thing here. Only difference হচ্ছে plus minus উল্টায় যাবে. Okay, so it's going to be like that. And our মাঝখানেরটা হচ্ছে কি ছিল? This is negative, right? So if that's negative, sorry, right, so এটা যদি নেগেটিভ হয়, নেগেটিভকে নেগেটিভের কাছে আনলে কি করবে? গেইন করবে। আর পজিটিভকে নেগেটিভ দিকে নিয়ে গেলে কি করবে? Lose করবে. So that's how the graph is going to look like. Okay, and all of this that you see here is going to be that value, and these are all going to be positive. Just উল্টে যাবে জিনিসটা, basically. That's it. Does that make sense? So এইটা হচ্ছে for individual charges out there. Now this graph actually has something else hidden within it. That something will be exploited. What is it? A graph mode, there's a quantity available that can help us justify our graph, explain our graph. What is that? Yeah, the gradient of the graph here gives us what? Electric field strength, but there's a catch. So look at this. এই যে আমার একটু কেয়ারফুলি শুনে এই পার্টটা আই ফিল লাইক তোমাদের এক্সামে আসতে পারে এবার দ্য গ্রেডিয়েন্ট হিয়ার is going to be what? Minus dv by dx, right? Do you get y minus? কারণ হচ্ছে minus পরে দেই dv by dx. Turns out this graph that we have here, এটা গ্রেডিয়েন্টের যে ভ্যালুটা পাচ্ছি is exactly same as what? Electric field strength, but with a catch. Catchটা কি? It's the negative of that value that gives you electric field strength. So আমি একটু এক্সপ্লেইন করে একটু কেয়ারফুলি আচ্ছা আমাকে একটু বলতে পারবা এটা কি পজিটিভ গ্রেডিয়েন্ট না নেগেটিভ গ্রেডিয়েন্ট? নেগেটিভ গ্রেডিয়েন্ট, রাইট? সো নেগেটিভ গ্রেডিয়েন্ট যদি থাকে আমার নেগেটিভ গ্রেডিয়েন্টের নেগেটিভ যদি নেই, what will I get? Positive, right? And that reveals to you the charge that you have, whether it's plus or minus. এই যে এদিকে না তাহলে উল্টা যাবে because it's the other way around. Okay, so electric field strength definition key. What's the electric field strength definition? It is the negative gradient of a what graph? Of v versus d graph. এখন এটা আমরা কেমনে হচ্ছে ইউজ করব? হ্যাঁ, এখানে যদি আসো, সো এখানে যদি সেমটা করা হয়, what do you get? নেগেটিভই পাচ্ছ এখানে। তো আমার হচ্ছে নেগেটিভ গ্রেডিয়েন্ট অফ a v। তোমার কোয়েশ্চেনটা হচ্ছে যে identify charge. No, you can only identify if it's repulsion or attraction. আচ্ছা আচ্ছা একটু ক্লারিফাই করে নেই। না, এটা পারবো না। Let me clarify something. Can anyone tell me if your electric field strength or force is positive versus force is negative? There was something about it. Positive force represents what? From gravitational field, we can remember plus minus F equals to minus gmm by d square. The minus there was a significance for what? Attraction, right? So minus হচ্ছে attraction আর হচ্ছে প্লাস হলে কি হবে? Repulsion, right? So আমার এখানে এটা কিন্তু পজিটিভ আসছে। What does that tell you? It's a repulsive force. এটাও কি আসছে? Positive. It's a repulsive force. আর যদি নেগেটিভ আসে, what does that tell you? It's an attractive force. ওইখান থেকে you can infer যে তুমি যদি পজিটিভ হও, the other has to be like the like charge of the unlike charge. Yeah. Right, but that's to investigate a field. But let's say there's actually genuinely a proton and there's an electron flying towards it. Can happen, right? For that you have these graphs. Okay, so let's say I have a positive charge and there's nothing interacting with me right now, so I want to understand how interaction would work. In that case, you imagine that charge to be a what charge? Positive. But if there's genuinely a negative charge out there, we still consider it negative and do our math. It's only when you have no charge to work with, the imaginary charge is always the positive charge. Okay, আচ্ছা তাহলে এইটা আমাকে বলতে পারবা কি হবে? আচ্ছা এটা আমি বলি, I will prefer if you guys don't memorize this. I'll show you কেমনে এটা বের করা যায়। বললাম না যে একটা যে কোনো একটা শিখো, আইদার এটাকে ভালো করে শিখো বা এটাকে ভালো করে শিখো। আচ্ছা লেটস সে এটা তোমরা বুঝছো, তাহলে এখান থেকে কেমনে আমরা ওটা বের করতে পারি? লেটস ট্রাই টু লুক ইনটু দ্যাট। ওকে, সো রাইট, সো এসেনশিয়ালি যেটা হবে এখানে, এই গ্রাফ যেটা দেখতেছো, এই গ্রাফটাকে ডিফারেন্সিয়েট করলে কোন গ্রাফ পাবা? এই গ্রাফটা পাবা। সো তোমাদেরকে যেটা করতে হবে, এটাকে হচ্ছে কি করতে হবে এদিকে আসার জন্য? ইন্টিগ্রেট, রাইট? সো এখন এত কমপ্লিকেটেড কিছু না করে আমরা একটা জিনিস চেক করি। এখানে ফার্স্ট অফ অল এর ভ্যালু কি পাচ্ছি? ম্যাক্সিমাম নাকি ম্যাক্সিমাম, রাইট? সো wouldn't that mean that the graph would be the steepest here? কারণ এটার গ্রেডিয়েন্টই তো এটা দিবে, রাইট? কিন্তু এটা একটা জিনিস নোটিস করে দেখো, ইজ এটা পজিটিভ হাই ভ্যালু অর নেগেটিভ হাই ভ্যালু? নেগেটিভ হাই ভ্যালু। না না না, এইটার গ্রেডিয়েন্টটা তো এটা দিবে। তাহলে এখানে হচ্ছে এটা কি পজিটিভ হাই ভ্যালু? তাহলে গ্রাফটা কোথা থেকে স্টার্ট হবে? এই যে এখানে যে গ্রাফটা হবে, এখানে ইজ দ্য গ্রাফ গোইং টু বি এরকম নাকি নিচে থেকে? নিচে থেকে। কেন নিচে থেকে আমি একটু বলি, তোমরা তোমরা তোমাদের নিজে চেক করে দেখতে পারো। আইল জাস্ট ক্যাচ এন্ড শো ইউ কি করবো আমি। One simple way out here is to memorize them, but let's try to first figure out without memorizing. So এখানে যদি দুইটা গ্রাফ কনসিডার করি, let's say you think যে কোনো একটা হবে, how do you eliminate and get the answer? এটার যে গ্রেডিয়েন্টটা পাচ্ছ এখানে, the gradient here, right? It's a what gradient? Negative gradient. Wouldn't the negative of the negative gradient give you what? Positive electric field strength, right? So তোমরা যেটা করছো, you just took the negative value, কিন্তু আমাদের নেগেটিভটাকে কি করতে হয় to get the answer? পজিটিভ করতে হয়। আর এখানে আমি বুঝছি তোমরা ক্লিয়ার না, I'll show you কি মিন করতেছি। আর এটা কি gradient? Positive. So negative of positive gradient will give your what electric field strength? Negative electric field strength. এখন আমাকে বলো কোনটা হবে? উপরেরটা হবে। কেন? বিকজ তোমরা যেটা করছিলা, তোমরা হচ্ছে ভাবছো যে এটা গ্রেডিয়েন্টটা নেগেটিভ, তাহলে তার জন্য এটা হচ্ছে সরি গ্রেডিয়েন্টটা পজিটিভ, তার জন্য এটা পজিটিভ ভ্যালু আসবে। বাট ইউ হ্যাভ টু রিমেম্বার, এটা ডিফারেন্সিয়েট করলে ডাইরেক্ট অ্যান্সার আসে না। ডিফারেন্সিয়েট করার পরে কি অ্যাপ্লাই করতে হয়? A negative sign. Because the definition is that the gradient, negative gradient of the graph gives you electric field strength, right? So in that case, আমার হচ্ছে এটা হওয়ার কথা। আমি পরে লেভেল করে দিচ্ছি। So we'll start from here. Next হচ্ছে, there's a place where, what is this? The electric field strength is 0 or minima. Minima, right? তাহলে আমার হচ্ছে এটা কমতে কমতে গ্রেডিয়েন্টটা কি হয়ে যাবে? ফ্ল্যাট হয়ে যাবে, but 0 হবে না। মানে it'll look very low gradient, but can't be flat. কেন ফ্ল্যাট মানে ইলেকট্রিক ফিল্ড স্ট্রেংথ কি? 0. আমার ইলেকট্রিক ফিল্ড স্ট্রেংথ কি এখানে 0 হচ্ছিল? না। So it'll become very low, and এখানে একটা কনফিউশন আসে। If you go to the other side, right? এই যে এই জায়গাটাতে, what value do you have again? Positive, right? So how do you draw this here? এই জায়গাটা কিরকম দেখতে হবে? Do you think the graph will look like this? এটা যদি assume করো, তাহলে তোমার গ্রেডিয়েন্টটা এখানে কি আসছে? পজিটিভ। তার মানে এখানে ট্রান্সলেট করতে হলে নেগেটিভ করতে হবে, বাট আমার তো ভ্যালু নেগেটিভ না, আমার ভ্যালু কি এখানে? পজিটিভ, রাইট? তাহলে গ্রাফটা অ্যাকচুয়ালি কোন দিকে যাওয়ার কথা? নিচের দিকে যাওয়ার কথা। ইটস সাপোজ টু বি লাইক দ্যাট। এন্ড এটা করতে গিয়ে স্টুডেন্টরা একটা মিস্টেক করে, এন্ড আই হ্যাভ সিন দিস ইন দ্য পেপারস। ওরা হচ্ছে এটাকে কোয়েশ্চেন করে অনেক স্টুডেন্টরা এরকম ড্র করে ফেলে। Is this the right diagram? Nah. But will there be a crossover point? Yes. How would that look like? Yes, very good. It'll look something like this. যে এরকম দেখতে হবে। It'll touch the x-axis, no problem, but it'll never be flat, because a flat graph here means that what's the electric field strength? 0, which has never happened in my scenario. Okay? Yes, bolo. Okay. আচ্ছা। এখানে স্টিফনেস আছে। আচ্ছা। But electric potential 0 মানে কি? What does that mean? No, between two charges. হ্যাঁ, so এখানে যে electric field strength, electric potential টা যে 0, what does that mean? Gradient of a straight line. না, এটা তো ডিফারেন্সিয়েট করে এটা পাচ্ছে। কোয়েশ্চেনটা হচ্ছে, what does this turnover point here represent? Change in charge. Weakest electric field strength. Equal electric field strength at that point. No. Equal electric field strength না। না, এখানে নাল নাই তো। এই গ্রাফটা তো অন্য গ্রাফ ছিল। নাল তো ছিল যে এটা। That's a null point. That's a different graph. Yeah, I'll explain কি হচ্ছে এটা। এটা তোমাদের পেপার আমি দেখিনি, but I feel like হচ্ছে জিজ্ঞেস করতে পারে। Least field strength. Yeah. Right. Well, yes. No, gradient is not 0, right? Here? No, but this one's gradient gives you that, not the other way around. আচ্ছা, আমি একটু এক্সপ্লেন করি কি। এটা জিজ্ঞেস করার চান্স কম। আই ডোন্ট ওয়ান্ট টু রুইন যেটা পারো তোমরা অলরেডি, সো একটু জাস্ট দেখে নাও। তোমাদেরকে কোয়েশ্চেন করতে পারে টু ড্র দি ইলেকট্রিক পোটেনশিয়াল লাইনস অ্যারাউন্ড দ্য চার্জ। I haven't seen any question like this, but I don't know syllabus can write acknowledged corner je nai ba aste, because it's something you should learn. Electric potential lines আমরা draw করে আসলাম. Do you remember how they were for gravitational field? These dotted lines like that. Null point there. No. So yeah, the net is 0. So let me clarify here. So look at this. This is what the diagram looks like. The electric field strength around two charges, right? যেটা আমরা draw করলাম. It actually looks something like this. এরকম দেখতে হয়. And as you approach the center, lines গুলো এরকম হয়ে যায়. Like that, then like this, and then like that, because they're becoming more and more what? Straight, right? So yeah. And on the other side, it's going to look like that. কোনটা? হ্যাঁ, magnetism right, magnetism আছে, but magnetism is different. Right, this is how the field looks like. যে জায়গাটা crossover হচ্ছে is the place where the line is what? Straight. Okay, diagram wise, that's what's happening. And if the charges are equal, তাহলে হচ্ছে this is exactly where at the center. So আমার যদি charges গুলো equal হতে crossover point কোথায় হতো? এই জায়গা থেকে. So all the values on this side of the line are what? Positive. All the values on that side of the line are what? Negative. What does it imply? Let's say you're a charge here and you're traveling from this side to that side. Work is done on you or by you, right? So look what happens. আমি যখন এদিকে যাচ্ছি, can you tell me, am I, as I go further away, am I gaining potential energy or losing potential energy? Losing. তার জন্য lose হয়ে যাচ্ছে. So lose করতেছো. And the moment you cross this, it's like you're crossing the infinite line for the other charge, because the potential value is 0. And now you entered the domain of that charge, and now you're falling towards that charge. So you continue to what your energy, lose your energy. This is basically a transient from going from a positive charge to a negative charge to a negative charge. So আমাকে একটু বলতে পারবা যে let's say you're here right now and you're moving from this side to that side. What is going to happen? The graph I've drawn here, diagram, no, like general, like charge, bolo. না, null point যেটা বলতেছো এটা হচ্ছিল for field strength. Potential and null point বলে কিছু নাই. Potential and null point মানে হচ্ছে strength is 0, which means you are at a place that's infinitely far away. That's it. Which diagram are you thinking about? The one that they both merged together? The diagram you're talking about, the other diagram is this. So this is like where they add up. ওটা মাঝখানে হচ্ছে মিনিমা হয়, not 0. এখানে তো 0 হয়ে গেছে ভ্যালু. ওটা হচ্ছে লাইক চার্জেস. Because they're adding up. Okay. আচ্ছা, এটা আমি পাশে রাখি. এটা I haven't seen. Have you seen any question on this? I don't recall seeing any. আচ্ছা, but দিতে পারে, because you know it's within the scope of our syllabus. বলো. Positive test charge, right? Because you're going away from the charge, so you're naturally moving away, so you're losing energy. Which one? এটা না, এটা লাগবে না. এটা যেহেতু না, I was seeing বুঝছো না, যদি বুঝছো তাহলে ভালো, নাহলে দরকার নেই. Okay, I don't want to emphasize on that. In this diagram, oh, in this one, it's losing. It's continuously losing, and it will only happen if you the value here. No, but it's a negative value. It's a potential graph, right? Negative potential means what? Losing, right? And then so let me clarify. Let's say you're a charge here, and you're moving towards this. As you go from here to there, you're gaining potential energy. And if you go from this side to that side, you're losing potential energy. So let's start from here. I'm moving away from here. So my value is increasing, right? So I'm gaining potential, gaining potential, gaining potential, and I'm still gaining potential and have reached the highest potential there. And if you go the other way, you're losing potential, losing, and you go here, you're further losing. Why is this loss negative? Because you're a negative, positive charge moving towards a negative charge, right? That is this graph here. You are, can we determine the magnitude of the potential from the graph here? We can, if you know the charge that you are. But because if you're a negative charge, then the answer would be similar, but it could be the other way around. Okay, before we wrap up, একটা graph বাকি আছে করে নেই। আমাকে তাহলে বলো, what should the graph look like for this one? তোমার হচ্ছে light charges. The electric potential graph. Yeah, so আমার এখানে হচ্ছে তোমরা sketch করে দেখতে পারো এক্সামে। What I can recommend is I've seen students do this. Just draw this and then see does it match or not. আমি দেখে কেমনে কাজ করব। What is the gradient here? Negative. তার মানে electric field strength কি? Positive, right? What is the gradient here? Positive. So আমার electric field strength কি? Negative. Let's go and see if that matches or not. আমার positive, positive, negative, negative. ভালো. But there's something else though. Right at the center, the electric field strength is how much? 0. Which means in this graph, I must have a place at the center somewhere where the gradient is what? 0. That matches that. Okay, so whenever you get a question like this, just sketch one and then rectify it. Should it be touching the x-axis? No. Not necessary. Which one is between two charges? There is no infinite. Infinite is on the other side, not in between. No, we assume that we point to আসছে from infinity ki lage. So you're coming from that infinity to this point. Or A charges, you're coming from that infinity to this point. Then you find the difference in both of them. Because potential is not equal. They can be different charges. If they're different charges, potential can't be 0. It's 0 only if they're like charges, equal in magnitude. So like this, if this is plus q, it'll touch. But if it is plus 4q and q, it'll be like a minimum. It'll be a minimum. Yeah, they're like charges, but equal like charges will touch 0. Because the potentials are exactly equal to cancel out. বলো ফার্স্ট পেপার কবে শুরু করবে? ফার্স্ট পেপার এপ্রিল জাস্ট তোমার ফার্স্ট পেপারে যে প্রবলেম আছে ওগুলো এটা ছিল এরকম না অন্য আইডিয়াল গেছে আচ্ছা আমাকে পাঠিয়ে রাখতে পারো মানে কম্পাইল দেবেন কি সেন্ড মি সো যখন ক্লাস করব স্টার্ট সলভ করব you can solve that problem.
It's really because I was outside because they didn't tell me about it. So
But you can give the ones of this week. This week, yeah, you can give it till tomorrow. ভালো তো পারো তো